Welcome to Real Civil YouTube channel. In last video lecture, we have seen the problem by using equivalent static method. In this video, we are going to use the response spectrum method. Okay, so this is the problem description. Consider a 4-story reinforced office building. Okay, important points I have highlighted here. 4-story and office building. The building is located in Shillong, seismic zone 5. The soil conditions are hard and or hard rocky. The entire building is situated on the raft foundation. The RC frames are infilled with brick masonry. This is the given data. Along with that, they have given the lumped weight due to dead load. That means dead load is 12 kilonewton per meter square on floors. Okay, so 12 kilonewton per meter square is on the floor, means typical floor, and 10 kilonewton per meter square is on the roof. Okay, so 10 kilonewton per meter square is on the roof. Similarly, the live load is 4 kilonewton per meter square on the floors and 1.5 kilonewton per meter square on the roof. Okay, so these are the loading condition. Finally, determine the design seismic load on the structure as per IS 1893-2016. Okay, so let's see some more details about the problem. So they will provide you the details of the free vibration properties, of the building for vibration in the x direction. So let's see what they have given. Here you can see the natural period is given in seconds. Okay, so this is the natural period. Okay, this is T1.860. That means this is the time period of the first mode, and these are the mode shape. Like suppose this is a 4-story structure, then this is 1, then this is 0. This is 1, this is 0.904, 0.7, then this is 0.4. So this is somewhat the shape of the mode shape. This is somewhat the mode 1 looks like. This is the mode 2. This is the time period of the mode 2, and these are the values: 1.216 minus 0.701 minus 0.921. These are for the roof, third floor, second floor, and first floor. Similarly, mode 3 values are given: time 3 or T3 0.145. This is, or if I draw this shape, this could be like this is 1 here. Okay, then minus here, again minus. Okay, so if I draw the mode shape, it's some this is the final story, then negative, then come here, and something like this. Okay, these are the mode shape values given. This is 1, here 0.831, here 0.574, and this is 1.016. Okay, so these are the plan dimension. Okay, so this side is 4 bays are there, 1, 2, 3, 4, and each bay is of 5000 millimeter. 5000 millimeter of each bay. There are total 4 bays, therefore This is, we can say, 20 meter. On this side, 3 bays are there, 1, 2, 3, and each bay of 5000 millimeter. So that means we will have this 15 meter total plan area. This is the elevation. Here you can see this is the first, second, third, and this is the final story, or we can say this is roof. 4.2, all these values are in millimeter. 4200 millimeter, 3200, 3200. Okay, let's move ahead. So first step here is to calculate the weight of the structure. Okay, so first we will calculate for the roof. Okay, here you can see roof. For the roof, dead load given is 10 kilonewton per meter square. Live load given is 1.5 kilonewton per meter square. We know that live load for the roof in seismic weight calculation is 0. Okay, therefore seismic weight of roof is, these are the planned dimensions as I shown you in the last slide. This is 20, this is 15. So 15 into 20 into this is 10 kilonewton per meter square. So if we do the multiplication, we will get the 3000 kilonewton weight of the roof. Similarly, story 3, 2 and 1, dead load given is 12 kilonewton per meter square. Live load given is 4 kilonewton per meter square. But we know that if the load, live load is greater than 3, okay, then we will consider the live load 50%. This is again one codal provision in IS 1893-2016. You can see our last video, we have done all the things there also. Okay, so seismic weight, here not roof, here seismic weight of story 3, story 2 and story 1. Okay, these are the planned dimensions, 15 meter by 20 meter. This is the dead load intensity, 12 kilonewton per meter square. This is again planned dimensions. Here 0.5 means we have to consider 50% if the live load is greater than 3, our live load is 4. Okay, so if you do this multiplication, all the things, you will get the seismic weight as 4200 kilonewton. Okay, let's see. Okay, now this is very important table, so pay attention. Now let's see one by one. First is story level. So as you know, in our plan there are 4 stories, 4, 3, 2, 1. Okay, these are 4, 3, 2, 1. Now next is the weight in kilonewton. We have just calculated the weight of the roof is 3000 and others weight is 4200 kilonewton. Okay, 2 columns are clear to you. Now next is we have to do for 3 modes, as we have 3 modes in our problem. Okay, so these are the 3 modes. Now this particular column represents mode shape coefficient. This is usually denoted by phi. This is I for the, we can say, ith floor and kth mode. Okay, that is nothing but this is phi ith floor, say 4, just a minute. Okay, 4th floor and mode 1, then 3rd floor mode 1, 2nd floor mode 1, 1st floor mode 1. So these values are already given to us in this particular slide. You can see here. We will use them here. 1, 0 0.904, 0 0.716, 0 0.441. Okay. Uh, Let me clear this. Just a minute. I will clear this so you will feel comfortable. I'll just reduce it. Yeah, that will be okay. Okay, we have seen this is story, this is weight, this is mode shape coefficient phi I k. Now what is this value? This value is simply multiplication of weight multiplied by mode shape coefficient. That is 3000 multiplied by 1. That's why there is 3000. Okay. Similarly, weight multiplied by mode shape coefficient means 4200 multiplied by 0.904. So that will give you 3797. Similarly, 4200 multiplied by 0.716, you will get 3007. Similarly, 4200 multiplied by 0.441, you will get 1852. Okay. Now this is how this column, or we can simply say that weight multiplied by mode shape coefficient. Now your third column is I will write here, weight multiplied by mode shape coefficient square. Okay. So weight is 3000 into 1 square. It's again 3000. Okay. Now I will show you for this particular calculation. 4200 multiplied by square of this mode shape coefficient, 0.904 square. So if you do the multiplication, you will get 3432. Similarly, 4200 multiplied by 0.716 square, you will get 2153. And finally, 4200 multiplied by 0.441 square. So you will get this value, 817. Okay. The same way, these other columns have been prepared for mode 2 and mode 3. Okay. I will show you for the mode 2. Let me erase. Let me erase this. Okay. Now similarly, we have done for the mode 2. These are the mode shape coefficient of the second mode, which is given here. For mode 2, these are the coefficient. So we have written down here. Now you have to multiply this mode shape coefficient with weights so that you will get here. I will show you two examples again. 3000 multiply by 1, you will get 3000. And for this second, 4200 multiply by 0.216. So you will get this 907. Similarly, you will get other values. Similarly, for this value, you have to multiply weight with the mode shape coefficient square. Similarly, what we have done in mode 1, similarly you have to do for mode 2 and mode 3. Okay, I will not repeat. If you feel any difficulty in this calculation, you can comment me, I will let you know. But these are very simple calculations. Okay, now here I have done the summation. Okay, 3000 plus 4200 plus 4200 plus 4200. Okay, simply I have done the summation. Plus 4200 will give me this answer. Okay, similarly I have done here. I have added all the things. Similarly I have done here. I have added all the things. Similarly you have to repeat for mode 2 and mode 3. Now we are going to calculate mk, that is modal mass. It is called as modal mass. I have written here the formula. Mk is equal to summation of phi I wi phi I whole square divided by wi phi I bracket square into g. So we know that this column represent wi phi I. Okay, so this value represent the summation. So only thing we have to do is we have to square it. Okay, that's why we have done the square 11656 square divided by g. I have written as it is. G you can take 9.81. Okay, now phi I wi phi I square. So we know that wi phi I k square. This is the column. This value represent the summation. Okay, so I have used this value as it is here. So if you put here 9.81, you will get this value. Similarly, square of this value divided by this value multiply by g. Similarly, square of this value divided by this value multiply by g. So I have just done the simplification work here and I have solved this. This is your modal participation factor mk. Now let me clear. I'll just clear this. Yeah, this table is very important. If you know this table, then there is nothing in the question. Okay. Now next thing we have to calculate is total percent of total weight. To calculate the percent of total weight, first we have to add these values. These three values. Okay. So 14,45, 123 zeros plus 95700 plus 1600. So if you do this calculation, you will get the answer 1556,800 as a grand total. Now you have to take the percentage here. So how this has been calculated? 144500 divided by 1556,800 multiplied by 100. We have just taken the percentage. So it comes out to be 92.6%. Here similarly 95700 divided by 1556,800 multiplied by 100, and similarly I have calculated this value. Okay, so this is percent of the total weight. Now we have to find out pk, that is nothing but modal participation factor. Okay, modal participation factor. So here simply what we will do, we will take this value, that is wi phi I k summation, okay, divided by this summation of wi phi I k bracket square. So you will get the values. Similarly 2905 divided by 822, you will get this answer. 1366 116200, you will get this value. Okay, now let's go ahead. Now this is our third step, we can say. So I will explain this only one so that you can do for other modes also. So what you have to do now, here we want to calculate design lateral forces, at each floor, at each mode. This is what we have to do. So I will explain you for the mode 1. So what you have to do, if you remember, for the mode 1, here they have given the natural time period 0.860. Okay, now design lateral force, the formula is, I will write down the formula, AK multiplied by phi I k multiplied by PK multiplied by WI. Okay, so if you have paid the attention, you will know this value we know, that means weight of the floor. This value we have just calculated in this table, that is PK. Phi IK means the values for the mode 1, means these are the values. So only thing remaining is AK, whose formula is given here. Formula is very simple, Z by 2 I by R SA by G. Z is the zone factor. Okay, so I think zone 5 is there, therefore 0.36. Importance factor is 1. Response reduction is 5. And now SA by G. So SA by G, in the given data they have told that for rocky hard soil, that means we have to refer this. Okay, you will get this in IS 1893 2016. Okay, so what we have to do here, we have to check the time period. Time period is 0.860. So that time period will be here, means greater than 0.4 but less than 4. So for that, SA by G value will be 1 by T. So 1 divided by t. So t is 0.860. So that's what I have written here, SA by G. So if you solve this, you will get the value. Okay, so put this value here. So Z by 2, I by R, and this is SA by G. So you will get the coefficient here. Okay, so this is how you have to prepare. So I have not put these values because we have to put the values here of the respective floor, means fourth floor, third floor, second floor, one floor, first floor. Similarly, do it for mode 2, and similarly you carry out the for mode 3. If you feel any problem in this, you can contact me, you can comment me, I will definitely answer it. Okay, now as I told you, we are calculating design lateral force. That formula is AK multiplied by phi ik multiplied by pk multiplied by wi. Okay, so only thing is here for mode 1, our AK value is, if you see, AK value here is for AH1 0.0418. It is 0.0418. Okay, PK value is, here we have calculated for the mode 1, this is mode 1, so 1.240, 1.240. Okay, now this value is fixed for mode 1, this value is fixed for mode 1, so here you have to put the values only. Okay, so prepare the table floor weight mode 1. Now put the mode shape coefficient. Now this value, how this value come, I will tell you. Okay, the formula is the right given here. Now if you want to write for the final floor, so AK is fixed. AK for the mode 1 is 0.0418 multiplied by phi ik, means mode shape coefficient for the final floor. So it is 1 multiplied by pk. For mode 1 it is 1.240. So it is 1.240 multiplied by wi, that is 3000. So you will get this value 155.5. Similarly, if you want to find this value, it is 0.0418 for mode 1 multiplied by mode shape coefficient 0.904 multiplied by pk 1.240 for mode 1 multiplied by weight 4200. So that will comes out to be 352.3. Similarly, you have to do the calculation for the remaining two. Okay, now for mode 2 you have these values, and how will you calculate? Again use this formula. Here your AK value of mode 2 you have to consider, or I will show you one sample calculation for the mode 2. So you will do, a bit long video, but because the calculations are so lengthy here, we have to finish this. Okay, now again I'll once again start from the formula AK, YIK, PK and weight. Okay, now for mode 2, value of AK is, here this is mode 2, 0.09, and value of PK for the mode 2 is, this is the mode 2 and this is PK for mode 2, minus 0.329, minus 0.329. Okay, I will show you here this value, how it come. Okay, so Q is equal to 0.09 multiplied by mode shape 1 multiplied by PK is minus 0.329 multiplied by weight uh, is 3000. So you will get this value. Similarly, you can do 0.09 multiply by, you have to select this for mode 2, 0.216 multiply by 0.329, this is minus, multiply by weight 4200. Okay, you will get this value. Similarly, you have to do for mode 2, mode 3. Okay, okay, now only few minutes and we'll be on the way to finish. Similarly, do for the mode 3, find the values of AK, PK will be constant for mode 3 and only floor values you have to consider. Now, this is very simple. Shear this value here directly, then add this value, you'll get this value, add this value, you'll get this value, add this value, you will get this value. Okay, same process here. Okay, as we have calculated the shear, the same way you have to carry out this process. Now next is calculating the shear. Here we are using summation of or square root of sum of squares method. So what we have to do here, I'll just clear. Okay, so what this method tell us, that for the final story or fourth level floor, for mode 1 the value of shear is 155.5, for mode 2 it is 88.8, and for mode 3 it is 31.9. So square these values and take the square root, means 155.5 square plus 88.8 square plus 31.9 square. So you will get this shear. Similarly, for the third floor, take the mode 1 value, take mode 2 value, take mode 3 value, okay, square those values and take the square root. Similarly done for remaining two. And if you want to find Q4, then here V4 is 182, Q3 will be 182, sorry, 371 minus 182. For Q2, difference between these two, and for Q1, difference between these two. Okay. So our base shear is means I have done this by equivalent static. Okay. In last video you can check in the description box link. In that same problem, equivalent static base shear was 1404. In this problem, base shear comes out to be 610 because this is value at the base and V for shear. Okay, so base shear value is 610. So you have to check which one is lower. So dynamic analysis value is lower. So what we do, we divide static value by dynamic one. We will get one factor here. 1404 divided by 610, we get one factor 2.30. We have to use this factor and we have to multiply all our responses by this value because this is the codal provision. So in last case we get 184, 182, 189, 139, 100. Okay, here you can see 182, 189, 139, 100 story shear. So you have to multiply all the values here by 2.30 multiplication factor. This is the code. What this we have to do as per the code. So code says multiply all the response quantities. So you will get this story shears. Okay. Like this is 419, 435. Like this we will get the values for each story. Okay. So this is dynamic analysis. If you have any problem, I know there will be must be so many doubts in your mind. Just comment it. I will respond. Okay. Thank you so much for watching the video. Please like, share, subscribe the channel.